From the projector.
Oh, I'll sort that out.
Okay, cool. So go ahead.
Mm-hmm.
Cool. Okay, good morning, everyone. Today we're talking about D3 or D3.js. Anyone have any idea what it stands for or what it does?
Is it data something?
Yeah, well, data, yes, that's one of the keywords. Simon?
I know, yeah. We can do the graph.
Okay, that's what it does. Good. So we've got half of an answer. It does graph stuff, good, and it has data in it. Okay, well, it actually stands for data-driven documents. So the 3Ds, data-driven documents, enter D3. So, So what is it exactly? It's a JavaScript library that is used to create graphical or visual images from data. The industry calls this data visualization. So you're essentially creating images from the data. Who wants to look at tables and numbers? If you've got an image that represents the data, either a graph or some visual representation, that's a lot more accessible than looking at tables and numbers. So it's a lightweight library, and I actually looked at the size, and it's only half a meg on a minify. And if you minify, it's actually 242K. So to me, that is quite a small library. It has a lot of functionality, so it might appear quite big, but in terms of byte size, it's actually quite small. So what you also notice as well, if you start digging into D3, it actually has a functional JavaScript paradigm. So lots of the way it's written is with the function in mind. So higher order functions, that's how it's been built. So if as a React developer, you'll just understand the idea straight away. It's not using a procedural or class-based system. It's more, okay, this function returns another function, which can be changed to another function. So for React developers or ES6 developers, it's almost like the same mindset. So who created D3? It's created by three guys in America. A guy called Mike Bostock, Vadim Ogeyevsky, I hope I pronounced that correctly, and a guy called Jeffrey Hurd at Stanford. They've now moved to the University of Washington, I believe. And it was based on a project called Protovis, which preceded D3. And as far as I can tell, it was first publicly announced in December 2012, but it might be earlier. But I think 2011 was the first year that I think it was publicly came into view. So why do I like D3? Other than having an interest in visuals or aesthetics, I think as a programmer, visual data is a lot more accessible than tabular or numeric data. And as developers, we're always having to manipulate information. At some point, we have to present that information, and I think visually is always a lot more compelling than tabular or textual information. So either a table, a chart, a pie chart, or some more complex things like chloroplasts and stuff like that, make it a lot more accessible. So also as well, D3 has got an impressive range of graphs and visual layers, and I'll show you some of those later on. And more importantly for us, newbies trying to learn code, lots of examples. Okay, the examples are old, version 3, which you have to refactor into version 4 or version 5, but there are lots of examples on the internet. And also as well, one of the creators, Mike Bostock, is quite generous with a lot of the examples he's got out there. So there's lots of examples out there you can actually look at and try and learn from. And I think for us who are trying to get into the industry, fintech and medtech rely a lot on visualization. So if you've got D3 or some charting or data visualization library in your arsenal, your skill set, I think it makes it a lot more marketable, in my opinion. And so that to me is a very compelling reason to be interested in D3. And more importantly as well, you've got D3 can be used as part of a component in the front end. So you bring your visualization, you add it to a dashboard, the dashboard shows a graph or a chart, and that is just a component within your React application. So as a library within a component within your React application, I think it's a win. So, in fact, before I do that, let me show you some examples to show you what it can do. So we've got box plots.
Sorry, Matt, did you mean to turn your mic off? Because at some point there the mic turned off. I don't know whether that's affected the sound or
Did I turn it?
Or someone has. If I turn it back on, then
Okay, sorry about
hopefully
that.
it should be fine.
Okay, so you can see this is just some of the samples. So you've got a calendar view, force directive view. I don't know if you could just jump into that if it's a live example. Okay, there we go, it's actually a live example. So, and this is purely D3. So all these nodes can be interacted with. Can I do that? Not for this example. Okay. On some examples, you could actually click on one of these. It can. So you see, I can click on one of the nodes, pull them away, and it pulls or manipulates the other corresponding or connected nodes, to it. Now that's just one example. That's called a force-directed graph. There are other examples, which I'll show you in a minute. So you've got the core diagram, schema graph, stacked bar charts, the tree map, lots of examples. I mean, some of the stuff I don't even know how you'd have to go about trying to interpret the information on that, but nonetheless, there are lots of examples which you could actually use. Now, one of the examples I like is this chloropeth, because essentially what you're doing is you're taking a graphical, or if like a map of a country or a state, and trying to superimpose on that some kind of information. So it could either be mortality rates, it could be voting patterns, Labour versus Conservatives, Brexiters versus Leavers. So in this example, let's see what they've got here. Well, this is unemployment rate. So I'm assuming, yes, the darker the number, or the darker the colour rather, the higher the unemployment. So they've got a value of 2 for very light to a value of 9, 10. So looking at this, the southern west coast of America has the higher unemployment compared to, say, the east coast, New York, Boston, and even Florida. Now, to me, that is a lot more accessible than looking at a table or some numbers on a piece of paper. So you get another view as to the unemployment rates in America. Again, I don't know what year this is, but that to me is a lot more accessible in terms of data understanding. And again, that's why I like data visualization. Looking at data, how can I understand? How can I visualize it to make it more comprehensible and share that understanding with people? Okay, so going back to our presentation, how does it actually work? Well, there's some key ideas in D3, and one of them is selectors. Now, D3 uses CSS3 selectors, and all the selections return an array. The array can be empty, obviously, if it doesn't find anything, but generally speaking, you'd have at least one element returned. So you can either select using tags, IDs, or classes. So in that sense, it's very similar to CSS3. I suppose Mike Bostock and his team decided to follow that CSS3 standard. An example on screen where you come across this particular syntax, D3 select or D3 select all. Whenever you see a D3 code, it always starts with a selection. And one thing you'll find quite weird about D3 is that you're selecting the elements you want to put on the screen before you actually select where you want to put it on the screen. So it may not make sense now, but at some point it'll click, because you're thinking, well, hang on a second, if I'm trying to add elements to the DOM, why am I selecting things I haven't put on the DOM yet? But it's there's a way D3 works that makes sense down the line. So once you've made a selection, you've got the styles and attributes which you can then apply to those elements, and of course then append them or remove them from the DOM. So what formats could D3 deal with or retrieve? It can deal with textual information using D3.text. It can deal with JSON files, surprise, surprise. XML, which I've yet to come across. And HTML, that's an interesting one, because I'm not sure if that means you could actually go and extract data from a website, or the HTML used to be formatted in a particular way. That is something I need to look into down the line. But the most common examples you'll find CSV and JSON formats in terms of retrieving data. You can also retrieve data in the TSV format, which is tab separated values. It's not something I've come across a lot of, maybe others have, but the most common examples I find in the codes I've looked at would be the CSV format and the JSON format. So, enter, update, exit pattern for dynamic visualization. Now, this is the core of the way D3 works. D3 has two sets, or two concerns, if you like. The data concern and the visual concern. And when you're making a selection, you're trying to basically marry the two together, or find an overlap. So the data needs to be represented on the screen, and you're trying to get D3 to try and manage that interaction between what the data is saying, if it's dynamic, it's changing, and what is actually, displaying. And so where that overlap occurs is where we're concerned with our selections. And so this whole enter, update, exit pattern is key and fundamental if you want to make D3 dynamic. If you're not concerned about dynamic visualization, then you can just use D3 as a very static library and just basically ignore the selection, just put the visualizations directly onto the screen. But if you wanted it to be dynamic, if you wanted to respond to the data, the enter, update, exit pattern is key to understanding the way it works. So, what is the enter pattern? Well, the enter pattern is trying to say, well, what data exists in my data pool, if you like, but doesn't exist in the visual area. And so it then has to say, well, this data needs to be represented at some point visually. So that enter data is stuff that's not yet visually represented and at some point needs to be represented visually. And the typical code you'll see for that is what we see on the right hand side. We've got a vast circle, so we're making a selection, SVG select all, so we're selecting all the circles. You notice it's saying all the circles. We're saying, well, where is the circle? It doesn't exist yet. That will be the visual element, which will appear at some point, but not right now. So we're saying, well, all these virtual, yet to be created circles will be matched with some data. So the second line, data in brackets, data, that's your data. The first selection, my virtual circles, which are yet to be created, will be matched with the data, and then it enters into view, so to speak. Yeah? And then we've got the other attributes like, okay, the x coordinates, y coordinates, and alpha radius. So that's the three minimum things you have to specify. So where on the x coordinate, where on the y coordinate, and at least how big or small the circle needs to be. So the three fundamental aspects of a circle, if you want to actually represent it and actually have some people see it. So that's the entry pattern. What about the update pattern? Well, the update pattern is, okay, we've got something on the screen, and we need to update it. D3 is concerned with that overlap, that join. So the data and visuals are now represented on the screen. So there's a match between what I have visual on the screen and what I have in my data in terms of my selection. So at this point, you can say all the circles which I've created have now been matched with the corresponding data element and are now visible on screen. So if we're updating it dynamically, a lot of the stuff we'll see will be around the update pattern. So we've done enter, there's nothing on screen, we collect that data, it's now on screen, and if we're going to update it, this is where this pattern, the update pattern, will be concerned with that management of the updates of the visual elements. And again, the code you'll see around that, you notice there's no exit or entry of the code. It's simply a selection of your visual elements. Again, you'll match the data, and then we then specify the attributes. So we've made a selection, and that selection matches the data, and we can then specify the attributes or move them around. So for instance, if I say had 5 circles on screen, and I want to move them to a different location, now that I've got those arrays, of elements, I can now manipulate them or transform them into another location. And the exit patterns, I'm going to ask a question. You can tell me what that means. again, what D3 is trying to do there is remove the component, so it's there visually, but the data doesn't correspond to that element, so it has to be removed. So for instance, if you've got the stock information and your chart is some information on the screen, if the data's changed or is no longer there, D3 needs to know it's no longer there and therefore remove it. So that's the exit pattern. So we've got the entry, update, and exit. So that pattern is fundamental to the way D3 works. So if you learn nothing else from my talk, at least have that stick in your mind. D3 for its dynamic visualization functions around this whole entry, update, and exit pattern or paradigm. So, talking about how D3 works on finding ranges. Most of it's on screen, but I think I'll focus on a little code snippet down in the middle there. So we've got something called, domain. Your domain is the expected data. So for instance, if you've got, let's say an array of numbers, we want to know how big that, what the maximum value is and the minimum value is. So if you've got numbers, say, between the range of 0 to 10, we know inherently that the maximum number will be 10 and the minimum number will be 0. But let's say we've got something a bit more diverse, population size or age ranges. We would need to find the maximum value and the minimum value of those age ranges of our data, not of the real population, but in terms of our data set. That would be your domain of data. So your domain is the data domain. The actual range is what you have on screen. So if you've got a 400 by 200 SVG element on screen, that's your range. So you want to map your domain, your data range, into your domain range rather, into your data range. So those two keywords, the domain and the range, are key to the way D3 works. So again, you're seeing the mix between its data and its visuals. The domain is your data, the range is your visual components. So this is always about mindset. What's my data doing and what are my visualizations doing? And it's trying to always manipulate those two things. So that's the paradigm that you come across time and time again. There are quite a few scale types in D3. Linear scales, the most common, logarithmic, and square root scales. Well, others as well, but they're sort of common ones you'll come across. Ordinal scales are a special case of D3 scale because you're not dealing with continuous numbers, you're dealing with a discrete range. So in the example I've given on screen, we've got, say, the letters of the alphabet. So they're quite discrete. And those discrete data ranges will match or be bound to your visual range on screen. So in this example, A would be matched to a range of 0 to 10 or 0 to 9. B would be matched between a range of, say, 10 to 19. Yeah? So the ordinal scales are, if you like, discrete. So they could also, so instead of, say, the alphabet, you could say have boroughs or countries. So I could say, okay, well, if I'm looking at data about voting records, it could be, okay, I'm looking at the borough of Newham, the borough of Westminster, the borough of Ealing. Yeah? So the ordinal scale is referred to discrete scales, discrete values, as opposed to continuous number range. So let's look at an example of some code. And I picked this example for Nico and Josue's team. So I hope they like it. So this is what it looks like. So that's the example. This is the pure D3 example. It doesn't do with React. That's what it looks like. So if we actually look at the code itself. Okay, so I'll ignore the first part, which is purely some styling. And this is your data set. So this is Germany's World Cup history. Now I can't tell you how accurate that is because I really haven't looked into it. I'll take the word for it and say it's actually accurate. So we've got an array of objects from 1990 to 2014. Now if I ignore that, let's go further down, look at the code some more.
Sorry, it says your mic is off again.
Oh, is it?
It's said that for a while. I'm hoping that we've still got sound. Yeah.
No, let me check that then.
Is anyone on YouTube? If they could check that.
Well, it's on my screen, yeah?
Yeah.
Yeah,
So maybe it's just mine.
it could be referred to you. Oh no, it's on your screen, yeah, so that makes sense. So it's indicating the state of Graham's. Yeah.
Hopefully not this one.
Okay, so we're looking at some code, weren't we? Okay, so remember I mentioned selections. So the very first active bit of code is the selection. In this case, we're selecting where the element will go into. So I've got a section called D3 container, which is up in, so that's my ID. Yeah? So it's just a H tag, which is the title, and the container. And this is where we're going to actually put that image, which was right. So that D3 selection is saying, okay, I want my imagery or my visualization to be in this section of my HTML. So we've made the selection. We're now going to append that selection to the DOM, and we've now specified the attributes of the width and the height. And those values are over here, so the width is 440 pixels wide and the height is 300 pixels. And the next step, after you've specified where you want your visualization, is to specify the scale. Now, this code is written in D3 version 3. In version 5, they've changed the keyword, so scale.linear is now just scale linear using camel case. So unfortunately, between version 3 and version 5, there's some breaking changes, so you need to be mindful of that. If you look at an example online, you have to understand what version of D3 you're looking at, and understand that if you're going to version 4 or version 5, there's a breaking change in terms of keywords that you need to be mindful of. So we specify the X scale, this is the horizontal scale, and Y scale is specifying the vertical scale, and it's also, if you notice on line 77, so we specified the horizontal scale, but we're also saying that, okay, I want my domain, my data domain, to be between the range of 1988 and 2016. So that's the range, the maximum range. So we've got what, 18 years there? What was it, 18 years? Oh, more than that, actually. And then the margin, the range, which is the visualization, is okay, what they've done there. So it's the margin is 20, and the width, so it's 300, so it's 20. So what they've done there, so the whole screen size, or wide, is 400 pixels wide. We subtracted 20 for the margin, and basically that's our range. So we're literally trying to keep the actual visualization within the boundaries of that we set. Again, that applies to the Y scale as well. Our domain is 0 to 220, and our range is, again, trying to keep within the bounds of the height. So we've got height minus margin, and then again goes to margin, which is 20. So we've made our selection, we've specified our scales, we're going further down, so what's the area we're going to actually try and compute for our visualization? So we're working on the axes, so we've got the X scale axis, and that's the year. Okay, I think it's probably best if I show you the. So we've got two axes. So we've got the numbers range here from one. This is position, and then we've got the bottom range here as well. So we're concerned with this y-axis and the horizontal axis. So the top goes for and goes against. So you've noticed that's the first y-axis. Again, let's go back to the diagram. So you've got that is the top part, and this is the bottom part, so that's y1. So this is y0, the top part here, and this is y1. Yeah? And we're charting the area, all this purple area within the top and bottom of the y ranges. And that is referring to our data. So you notice our data here is, that's the data, Germany underscore cap, which we saw up here. Now, it may look like there's a lot going on, but I think the key thing you've got to understand about D3 is that there's a lot of boilerplate code. So provided you put in the right, provided you get the data in the right, provided you give it the right data and you're not changing too much of the boilerplate code, then you're good to go. I think when it gets complicated, if you're trying to create clever computations or try to manipulate the data, but in terms of once you've got your data in the format which D3 expects or which you have simplified for your own purposes, all we're doing is basically selecting where we want it, specifying the scales, specifying the attributes, and the more tricky part is specifying the axes and the actual labels down the side. So from my experience, trying to get these things right is the more trickier aspects. Creating the chart is easier, but trying to get the labels in the right place and these axes can be a bit more tricky. And so I'll admit from the get-go that I tend to rely more on boilerplate code, but as you get more proficient with D3, you can start manipulating where you want your axes and how you want them in terms of on the left-hand side, the right-hand side, and then vertically as well. Okay, so we've got an append of the text here. This is all to do with the actual text we're placing on the screen. We select the text, we specify the location, and then add it to the screen. So goal text for goals 4, text for Germany's World Cup. And again, year labels, we specify the locations, and actually append that to the screen as well. Say a bit more about that, but I think I'll leave that there for now because that can be a bit probably overwhelming the first time you're looking at D3's code. So the key idea about React and D3 is they both want to manipulate the DOM. React has its virtual DOM and D3 tries to update the DOM because it needs to know what's on the DOM to compare that with its data and then try and update its visual elements. So the question is, if we're going to use both of them, who takes precedence? Who's the boss, basically? And there are different ideas on the internet. Some people the mind say, okay, well, let React manage the DOM and let D3 do the computation. And so if you're very competent with React and D3, that's the way to go, because you're letting React do its virtual DOM manipulation, and it's good at that, and it's quick in that sense, and you're using the power of D3 and its visualization library and methods, and handing over to React to basically present visual components. If you're still trying to get to grips with D3 and React, and you don't want to do too much refactoring, it's probably best to let D3 do the manipulation and also let React hand over aspects of the DOM let D3 that sense present on screen. Because if you try to let D3 or try to let React do the manipulation, then you essentially have to understand enough of how D3 works to take the elements D3's created and then give that to React so that React can then compute it. Now, I think for most of us here, that's a bit of an ask. So I recommend for us newbies at this moment in time, we don't go the route of DOM and D3 into working in that sense. We let D3 do a lot of the work for us because it is a lot easier to basically refactor the code and get it working. As you get more proficient with D3 and React, you can then say, okay, well, D3, you do the computation, give me the elements, and I'll go and render them in React or Vue or whatever library I'm using at the time. So there's two mindsets there. React does all the visual stuff, and D3 the back end, or you let D3 come to the forefront, do the computation, do the manipulation, the fetching, and then hand over stuff, or hand over stuff to the DOM. And we could look at another D3 example, but this time it's in Java, it's in React rather. And very, very quickly, I'm running out of time. I'll quickly just show you an example in Okay, so this is an example in React. Now, do I have this running? Let's see if I can actually run it. So, npm start. I tested this yesterday, so hopefully it works, and there are no errors, he says. Okay, cool. So that is a D3 rendition within a React application. Okay, it's not dynamic because it's not responsive data, but as a simple test of it working within a React application, it works. So, how is it working? There's our bar chart, and so obviously you can tell that's a component. And if I now go to my components folder, there's the function there. So let's go to the very top. Use of imports, it's using hooks, so we've got the use effects, use ref. That's all fairly familiar. Oh, key thing here, I did say with the newer version of D3 that the keywords have changed. So I mentioned scale.linear, so dot notation in version 3. In version 4 and 5, it's changed to camel case. So if you're going to look at code on the internet, mindful of the version, because it's version 3, keywords, we've got some breaking changes. So scale is not scale.linear, it's now scale linear. Okay, this looks like standard React. We've got use effect. So what we're doing here on this particular line is, okay, is the data there? And is there a component on screen? Yeah? Is there data? And is there an element on screen? If not, we can, if there is correction, if there is, we then specify we make a selection, which becomes our SVG component, or SVG selection rather. And we're now computing the values again. So we've got what's the maximum range of my data. We're specifying the scales, both the X scale here and the Y scale.
Just undo that, Max, otherwise you'll crash your app.
Sorry?
You dragged things, so just undo your last move. That's better.
Okay, good, so. I'll use cursor instead. Okay, so go further down. So we're now specifying various things. So you notice in append in line 38, where like before we go to line 38, line 34. So the SVG is the element we're trying to represent on screen. We're appending it, and D3 has this particular keyword, which is G, and it refers to trying to group all your visual elements together so you can manipulate them as a group, as opposed to trying to manipulate them individually. The G word seems to be a keyword to try to say, okay, look, aggregate all the elements together and let me manipulate it as one block. So the reason that's important is because if you're trying to move the visualization, and in this case of line 34 is doing that, is trying to move it margin left 20 and top, margin top 20. So it's trying to move it 20 to the left, to the right rather, and 20 down, because obviously it doesn't want it to be in the top left-hand corner. It's trying to move it slightly down, so it's, it's basically outside of the borders. Hence, he wants to group all the elements and then move it as one block. So we've done that. Now we've got to select all, which is the bar. We say, well, again, we haven't got the bars on the screen yet. It's selecting them because we need to create the visual elements before we then map them to the data. So do you remember I said about the enter, update, and exit cycle? So we've got select all, select what? My bars. We haven't got any bars yet. We soon will be. And we then match it with our data. So that is the classical selection for enter. So we've got select all, data, and line 49, the entry. Yeah? If this was a dynamic visualization, at some point we'll have an update, an exit criteria, but because we're simply rendering a static graph, we're only concerned with the enter. So we've selected our bars, we've attached them to a data point, and we're now entering them onto the screen. And that's essentially the crux of it. We then specify attributes like the size, the strokes, but the key thing is that we made our selection of the bar components, it's matched to some data components, to data elements, and we're now putting that on screen. So that overlap between the visual element and the data is what D3 is concerned with, and those three lines, 47, 48, and 49, are a pattern you see time and time and time again in D3. So entry, update, exit, that idea, you see that in code all the time. Yeah? And I think it's worth keeping that strongly in mind when you look at the D3 code. So that's our entry point. Now, because we're not changing any more data, we're not doing anything dynamic with the visualization, we won't see an update, we won't see an exit, because we essentially just say, well, here's the data, it's static, put it on screen, and that's it. The rest of the code is concerned with drawing the axes, and I won't bore you with that, so I'll leave it at that. And then we're simply, at the very bottom, we're simply returning our components. So we've created our SVG element, it's composed, and we're simply returning that to our app.js here as a bar chart, which is what we see here. Okay? I know that's a bit quick, but I'm still learning it myself, so I hope you understood some of it. But if you want more resources, I can point you to these resources online. Now, Mike Bostock's website, blocks.org, is very good. He has lots of examples. And there are two personalities on YouTube which I recommend you have a look at. One is called Swizek, and the other person is a woman, I think she's called Shirley Wu. She's quite good actually. In fact, I think she's very good. Her visualizations are quite inspirational. So I recommend, if you are interested, you check out her not tutorials, I suppose talks and seminars. And this chap here as well, Swizek Keller, is also good as well in terms of D3 and React. So those YouTube personalities, I highly recommend those two. But in terms of the authoritative source, I cannot recommend anyone higher than Mike Bostock himself, which is right here. That's his side of examples. I mean, that is quite extensive, yes, so those are the more popular ones, but yeah. You can just focus on that, which is what Shirley Wood does. She focuses on visualization, and yeah, it's I would say a minefield, but it's an interesting but a very consuming interest. So you've got to be careful. How far do you take it? Really get into it and ignore React? No, don't do that. Don't do that. And that's it, guys. I hope you found that interesting and not too overwhelming and too quick. Thank you very much. Any questions?
How did you get into it?
I looked at it, I think, early in the year, I think March or April this year. I was trying to graph some data to do with vaccines. And
Is that what you're...
well, I've got an interest in that health topics, and so I thought, what can I use to graph some World Health Organization data? So I was looking at D3 at the time. I didn't quite understand it enough to make use of it, but it kind of stuck with me. So I thought, okay, at some point, I'll go back to it and learn some more.
Do you know any examples of companies or organizations that have used it?
Netflix, Financial Times. Financial Times use it heavily, actually. New York Times. I think Uber do it as well. A lot of companies are taking D3 and actually create their own libraries on top of it. So it's quite used by a lot of big corporations. So any company that needs to do manipulate data will at some point have to use it. But I think Netflix is a big one, because that's probably they talk about it openly that they use D3 for their visualizations. But the papers, especially the New York Times, Financial Times, they are big users of it as well. In fact, Mike Bostock used to work for the Financial Times, the New York Times in the States. So that's where he probably developed a lot of the stuff, ideas that he's developed into D3. But yeah, it's heavily used based on that corporation. So I recommend if you've got an interest in the area, definitely pursue it. Yeah, right. Who else on today?
No, not at all.
Cool.